Hey, what's up guys, Alias here. In this video I will show you how to use ESP SmartConfig Flutter package to send the Wi-Fi credentials to an ESP32 device. Let's start by looking at the final product in the action. Right here on my smartphone I have the Flutter app we are going to build. Currently the ESP32 device that is laying here on my desk is not connected to any wireless network. I will use this app, which employs the SmartConfig esp-touch protocol, to send the network credentials and enable the ESP32 connect to the internet. Now I'm entering the Wi-Fi network name and password into the app. Once I press the Start Provisioning button, the app will send the credentials to the ESP32. Watch closely as I tap the button on the app. Also, keep an eye on the terminal. This terminal is directly connected to the ESP32 device and will display the logs in the real time. Look at the terminal now. As soon as I press the button, the app starts sending the credentials to the ESP32. You can see in the terminal that the ESP32 has received the credentials and is now connected to the wireless network. The app has also received connections feedback from the ESP32, including IP and the MAC address of the device. This means the ESP32 is now connected to the router and can communicate with any device on the local network as well as the internet. Stay with me and I will show you how to build this app from the scratch. Let's get started. For this project we will use the esp-SmartConfig Flutter package. I wrote this package a long time ago while I was working on one of my private projects. The package is completely open source and available on the GitHub. You can find a link to the repository in the video descriptions below. There is also other packages on the pub.dev that you can use for the same purpose. Even at the time when I was developing this package there was other packages available, but I found them a bit complex and not easy to use. Maybe they have improved now, but there is one thing that differentiates my package from the others, and that is the fact that this package is written in pure Dart language, while others are written in platform-specific languages like Java or Kotlin. This makes my package more flexible and easy to use in any Flutter project. That means you can use it on any platform that supports Dart except for the web, because web doesn't support opening raw sockets. Okay, let's start by creating a new Flutter project. Open your terminal and navigate to the directory where you want to create the project. I will create mine on the desktop. Run the following command to create a new Flutter project. Here we are creating a new Flutter project with the name esp-SmartConfig_demo. The flag Platforms Android is used to create the project only for the Android platform. If you want to create a project for both Android and iOS, you can remove this flag. After the project is created, navigate to the project directory. While in the project directory, execute the following command to add the esp-SmartConfig package to the project. Now open the project in your favorite code editor. I will use the Visual Studio Code. All the code we write in this video will be available in the video descriptions below. Let's start by creating the UI for the app. Open the main Dart file and remove all the code. We will start from the scratch. Create new file provisioning screen. This file will contain the UI for entering the Wi-Fi credentials. File is going to contain a stateful widget named provisioning screen. For now, let's just return an empty scaffold widget. Go back to the main Dart file and use the provisioning screen widget as the home screen of the app. Run the app to see the empty screen and make sure everything is set up correctly so far. I will run the app on my real device, but you can run it on the emulator if you want. If you see the blank screen, then everything is set up correctly so far. Let's continue by adding the UI elements to the provisioning screen. Elements we need are text fields for entering the wireless network name and password. We also need a button for starting the provisioning process. I will also add an icon for the nicer look and small descriptions of the app. To make UI look even better, we can add some gaps between the elements. With the UI elements in place, we can now add the functionality to the app. Import the esp-SmartConfig package in the provisioning screen file. Create a new function that will be called when the Start Provisioning button is pressed and attach it to the button. In this function, I will create a new instance of the provisioner class from the esp-SmartConfig package and use esp-touch v1 protocol. Package supports also esp-touch v2 protocol. Because I'm going to show dialog while the progress of the provisioning process, I will register a listener to the provisioner. Listener is going to be triggered once when the device is provisioned, and there we can close the progress dialog. Here we can start the provisioning process by calling the start method on the provisioner instance and passing the network name and password as arguments. You can pass all zeros for the network BSSID. Don't ask me why, but it works. I'm thinking of making this argument optional in the future. And immediately after the provisioning process is started, I will show a dialog with the progress of the process. Once when the dialog is closed manually by the user or the device is provisioned, I will stop the provisioner if it's still running. If the device is provisioned, variable response will not be null and we can call the onDevice provisioning method. This method still doesn't exist, so let's create it. This method receives the response from the device and displays it in the dialog. The response contains the IP and the MAC address of the device. And basically that's it. We can now test the app. Before we test the app, make sure the ESP32 device is connected to the power source and is ready to receive the credentials. I have already uploaded the firmware to the ESP32 device, so it's ready to receive the credentials. On the right side you can see the terminal with the real-time log from the ESP32. Enter the Wi-Fi network name and password in the app and press the Start Provisioning button. The app has successfully sent the credentials to the ESP32 device and the device is now connected to the wireless network. The app has also received the connections feedback from the ESP32, including the IP and MAC address of the device. In the terminal, you can see the logs from the ESP32 device, confirming that it has received the credentials and is now connected to the network. This means the ESP32 device is now connected to the router and can communicate with any device on the local network as well as the internet. And that's it for this video. I hope you enjoyed it. If you have any questions, feel free to leave them in the comments below. Thanks for watching and I will see you in the next video. Bye.